Hello everyone, in this video we are going to be talking about how we can graph some linear equations. So in this video it's kind of a basic introduction and a relation to plotting points on a coordinate plane and substituting values into an equation and solving for a missing variable. So there are multiple other ways on how to graph a linear equation, and we'll get to those as we continue making videos on pre-algebra. If you're curious though and you need to figure out what are other ways I could do this right now, I'll put a link in the description below of a video I've done for my algebra course talking about how we could have graphed this using slope-intercept form. All right, well, let's dive in. First of all, what is a linear equation? It's an equation whose graph is a line. So when you take the equation and you figure out some coordinate points by plugging in values for x and solving for y, which we'll do on these tables in just a minute, and you plot those points should lie in a straight line. Whether that line is diagonal going uphill from left to right, diagonal going downhill from left to right, or horizontal or vertical. We're not going to look at any horizontal and vertical lines in this video. That'll be the next one that we do on the channel. The points on the line are solutions of the equation. So this is a very important piece of information as you continue throughout your math career, because not only linear functions or linear equations act this way, but all nonlinear ones do as well. So when you start graphing equations, the graph is simply a visual representation of all the solutions to that equation. So it's very cool. All right, so let's look at some examples. Number one, we have y equals 2x minus 3. So I've set up a little table here, and these x values I've just chosen at random with a little bit of decision making involved there, because I wanted the points to fit on our coordinate plane, right? And the one that I have visible here. So I decided here to go with 1, 2, and 3. So what I'm going to do is I'm just going to take 1 and I'm going to plug it in for x, and we're going to solve for y. So that would be 2 times 1 is 2, and 2 minus 3 would be negative 1. So now we would have the point 1 comma negative 1, and we can plug that or plot that on our graph. So 1, 1, okay? Or excuse me, 1, negative 1. All right, now let's do the same thing for 2 and 3. So 2 and then 3. All right, so 2 times 2 is 4, and 4 minus 3 would be 1. So this would be 2 comma 1. So we can plot that, 1, 2, and 1. And then this would be 2 times 3 is 6, and 6 minus 3 would be 3. So this would be 3 comma 3. So 1, 2, 3, 1, 2, 3. Now I'm going to draw a line through these points. That is not that great, so let me fix that. There we go. I will put arrows on the end because once again, this equation, or there are multiple solutions, right? There are an infinite amount of solutions, really. Now, not every solution, not every coordinate is a solution, right? But that line is going to extend in both directions, so I put arrowheads on the end of that line, okay? All right, now let's look at example number 2. Here we have y equals 1/2 x plus 2. And so now notice my x values are either 0 or they are even numbers. It's just going to make the math easier for me, because what am I going to do when I plug something in for x? We're going to take half of it, or we're going to multiply by 1/2. So it's going to be a lot easier for me if I don't want to work with fractions to use even numbers or 0 with this one. So we'll do the same thing. Y equals 1/2 times negative 2 and then plus 2. So half of negative 2 would be negative 1. And then we add 2 to negative 1 and we get 1. So we're going to say negative 2, 1 would be on our graph, and that point would be right there. Let's do y equals 1/2 times 0 plus 2. So half of 0 is 0, and then we add 2 to get 2. So 0 comma 2 would also be on our graph. And the last one for example 2, we're going to plug in 2 for x. So half of 2 plus 2. So half of 2 would be 1, and 1 plus 2 is 3. So we get 2 comma 3. So 1, 2, and 1, 2, and 3. Now we're going to draw our line through there. Totally missed the points, but it's okay. We can adjust the way our line looks, and that looks good. All right. And our final example for this video, y equals negative 3x. Okay, so we're going to draw or write that in right there, and let's plug our values in. So once again, just chose some values around the origin for x, negative 1, 0, and 1. So this is y equals negative 3 times negative 1, which would just be 3. So negative 1 comma 3, 1, 2, 3. Then we're going to plug in 0 for x, so y equals negative 3 times 0. And we know that's going to give us a value of 0. So 0, 0, also known as the origin. Very good. All right. And the last one is 1, so -3 times 1, and that is just going to be -3. So that's 1, -3, 1, 2, 3, and we can plot that on our graph, draw our line. Hey, that one's pretty good. And that will conclude our video. So thanks for watching. That's a little bit about how we can graph some linear equations.